So I've got my first proposal for the layout of the building. What I haven't done yet is actually specified for it that it is a school. So if I go to the Analyze tab and I go to the Energy Settings, I can set the occupancy type for the building that I'm proposing studying. I'm going to tell it at this location that it's a school or university. That finds the occupancy loads, which determines things like how much equipment are associated with a school, how many people per square meter, per square feet are associated with the school. I can also decide whether I'm going to create an energy model, and I'm just going to use the option of saying that I'm not creating any kind of perimeter for the energy model. I just have one floor that runs through the school with no additional zones being created. They're just going to be the gymnasium and the classrooms. I can specify the construction type here. I'll show you that later that you could change that, but this is where for the walls or the interior walls that it creates or the roof, it's going to get values such as the R value for insulation. If I want, I can go in and specify the percentage of glass to be applied overall to the whole building, each face on the building, the sill height, whether the glazing is shaded, percentage skylights, HVAC system and operating schedule. I'm just going to go with the defaults because I want to just show how this would work. So if I pick my, if I pick my masses that I've got here, this is the classrooms and the gymnasium. So I selected them. The one thing I want to do is tell it that there's a floor that runs through the buildings, and there's just the one floor, which is the level 1 or the ground plane of my project. And that's how I tell it that I'm actually ready to study the building. So as soon as I did that, you saw that I got the percentage glazing on the surfaces of my building. I'm actually ready to go ahead and make the study. So if I go to Analyze and I say Analyze the mass model, I should have maybe named it, but it will give it a default name. So the project will show up. Now the change of color indicates that it knows that these are surfaces. Up here, I'm going to call this baseline, and I'll say it's north south because that's the orientation of the buildings as I have them at the moment. And I'll say continue. This is where it's doing the cloud computing. So it's sending the geometry of the model via the internet to powerful servers, and those servers are processing that data along with the weather station data to produce a report. Now if I quickly turn to the results and compare, I should actually be able to see up here. So it renamed it Project 123, and it's 90. Oh, sorry, it's Project 125, and it's 90. It's going too fast for me. It's 96% done in producing that study. So I actually don't need to wait for this. I can continue down here, and you'll see if you watch the bottom right of my screen, as soon as the report's finished, up comes the alert that tells me that the report's ready. Right, so I could click on that, or I could go back to look at it. And what I'm looking at now is, if I look at this baseline study, let me just scroll down. I've got another study running in the background, but if I scroll down, there's my site, there's the surrounding buildings. Here's the data about the temperature. With a school this size, it's 7,200 square foot because it measured that. That's enough for 167 people. The important value here is the life cycle energy cost of $171,000 over the course of 30 years. We're making some assumptions about how things will change over that 30 years. And I can see more information. I won't talk about all of it, but if you look at, say, the monthly heating loads in Gainesville, Florida, and the monthly cooling loads, and along with that, the kind of identification of what are the contributing elements to the load. For example, the occupants in yellow, looks like the school maybe is closed through the July because the yellow color's not there. So that you can create kind of a baseline study like this. You'll see weather data, the prevailing wind, and an average for the year comes from the west-southwest at 11 knots. It'll show the frequency. I shouldn't have said that. I said the strongest winds come from the west-southwest, being about 11 knots, but the frequency of the winds is generally more from the south than it is from the north. But it also changes by month. And so down here you're seeing month by month the windroses. You're also seeing, for example, the average daily minimum and maximum temperature for the month of January, February, March, so you can see the performance of the building. And so I'm going to get out of that and I'm ready to do a second study. I'll stop just now and then I'll get ready to turn the building and do a second study.